Hello, my name is Max Ruther, and I read the paper EmoNets, Multimodal Deep Learning Approaches for Emotion Recognition in Video by Kahou et al. In 2016. So in this paper, the authors discussed the techniques they used to win a data science competition in 2013. They were given a data set of video clips from feature films, each depicting an emotion being acted out. The challenge was to accurately classify those depicted emotions as one of the 7 labels: anger, disgust, fear, happiness, neutrality, sadness, and surprise. The authors won by using an elaborate combination of several models, where each of those submodels was dedicated to capturing a unique modality of the video data. To interpret facial expressions, they used a CNN and a bag of mouths model. To interpret audio, they used a deep belief network. To interpret motion and gestures, they used a relational autoencoder. The CNN for facial expressions appeared to be the most informative of these models by a considerable margin. The authors consider it as primarily important to their work that they made an interesting choice in the way they trained the CNN. They only trained it on external data sets, 2 publicly available ones. They did not use any competition data to train their CNN, and they credit this choice as a primary factor of their success. They found that when they trained it on the competition data, it always led to overfitting issues. To combine the various models, the authors tried a few different methods: simply averaging the models' predictions, concatenating together the models' predictions, and rigorously searching for a fitting linear combination of weights. This last method was found to be optimal, and the authors consider that combination technique to be their most important finding. To describe it in more detail, it randomly searches combinations of weights where a weight is given to each class in each model. So for 4 models and 7 emotion classes, this came out to 28 weights, which for the authors took hours to search to find the optimal combination. The authors consider as their most important findings this random search method of model combination and their training of the CNN on external data sets only. In their conclusions, they claim to believe that these models might be more broadly applicable, but they never clarify what they mean by that, instead reiterating what motivated their various choices during the competition. The first of a few main learning takeaways that I left this paper with was the success of training a CNN on external data only. I intend to give this a go in my own group project, which also focuses on emotion recognition, but of still images rather than video. Another main takeaway was the crucial importance of combining models thoughtfully, as it here accounted for an 8% difference in accuracy between the best and worst combinations of models. What I liked most about this paper was the depth of its explanations, which it offered for each of the various models and combination methods. This might be my first exposure to video data processing, so it's very helpful to have such a wealth of information and such a variety of methods on display here. I also enjoyed seeing how a video can be broken down into different facets like stills, audio, and motion between frames. What I disliked most about this paper was how the sections on model combination lacked any reference to the literature. Given how the authors held this area as the most important to their success, and also given how the preceding sections contained ample citation, the lack of it here was especially striking, and it affected their credibility with me. Because of this, it feels unearned and implausible when they then go on to claim that their model combination method is novel and broadly applicable. As I mentioned a few slides ago, my group project also concerns emotion recognition, so much of this is applicable to our work as well. Primarily, I intend to try using a CNN that is trained only on external data, but that's among other training choices that I intend to try out. I'm also curious to try the bag of mouths method that focuses on analyzing mouth areas for expression, but I suspect that might be out of my league for my experience level, but I'm interested in exploring it. Thank you so much for watching. I enjoyed this paper and this assignment. Have a good one.